with Janus.
Yep.
See how that works out. So thanks for being here.
Thank you to
Take
you.
it away.
It's a pleasure. Okay. Thanks for coming. And I'm going to explain how you can make a SIP phone into your browser to make audio and video calls. And we are going to use WebRTC technologies with Asterisk and two different libraries. One is sipML5 and one is Janus Gateway. I'm Alessandro Polidori, and I'm a senior software engineer at Netesis, that is an Italian open source company. Here are some of my contacts. Okay, first of all, let's start speaking something about WebRTC. As the word suggests, it enables a communication between browsers in a real-time, peer-to-peer fashion. And it's not a single technology, but a set of different technologies. It is composed by three fundamental APIs that are get user media, RTC peer connection, and RTC data channel. The first is used to access your media devices. The second does some operations such as the data negotiation. And the third does the real-time communication, the data transfer. Other API exists, but it's not important for this talk. So some real-time protocols are used, some for the data transmission and other for the signaling. And in particular, we need some signal to negotiate and establish a session before the data transmission. And the most used protocol in this field is the SIP protocol. We can achieve the security to have encryption and message authenticity using the circumversion of the protocol. SDP is used to describe the session before the data transmission, and other protocols are used to overcome some network problems related to the NAT. For example, STAN is used to get your public IP address outside your local area network, and the TARN does the media relay of all traffic, so it requires a lot of bandwidth. Okay, this is the overall architecture of the system, okay? And we can see from this picture that there are many components. And the two most important are the web application and the server PBX. But we're interested only on the web application because we want to make a SIP phone into the browser to make audio and video calls. Okay, codec are another fundamental part. In the audio section, the most used are Opus and G711. And in the video section are the H.264 and VP8. VP9 is not completely supported by the browsers, and AV1 seems to be the future. We at Netesis have made a phone switchboard system called NetVoice and NetCTI on top of it. That is a web application with the integrated WebRTC phone to make the calls. During the years, we have made two different implementations in production on some thousands of customers, and now we are going to see the implementation that uses sipML5. sipML5 is a JavaScript library, and it has been the first implementation of an HTML5 SIP client. It was presented at Google I/O in 2012, and its characteristics are that it's 100% pure JavaScript. It realizes a media stack, of course, based on WebRTC. It uses SIP protocol over WebSocket for the signaling, and with it, you can make audio video calls, but not only. You can realize also an instant messaging or screen sharing and so on. And it supports both desktop and mobile platforms. Okay, this is the overall architecture that we have used realizing the SIP phone with sipML5. The HTML5 client realizes both SDP and the SIP stack that we have previously seen. And the SDP describes the session, for example, which audio codec will be used. And the SIP realizes all the SIP stack that communicates over WebSocket transport. And after the session has been established, all the media data transmission is exchanged using some protocols and using WebRTC technologies. All of these components communicate with NetVoice PBX. Okay, now we are going to see how to implement a SIP phone using sipML5 with only 4 steps. So, first of all, you have to initialize the engine. In this case, there is the global JavaScript object called sipML, and we call the init method. Then we start the SIP stack. At this point, we can register the phone extension to the server PBX, calling the new session API, and at the end, we can make a new audio and video call. Okay, some more code. Let's see it in more detail. First of all, of course, is the inclusion of the JavaScript library, only one file. Then we initialize the engine, so we call the init function, passing to it two parameters, two callbacks, one to manage the success of the operation and one for the failure. And if all goes well, we are going to create the SIP stack, to start the SIP stack. And the parameters needed are the server address that can be on the cloud, and you can realize, for example, a cloud phone, or also on-premise. Then we pass the SIP extension URI that is composed by the protocol SIP, the extension identifier, and the server address, the password of the extension. Pay attention to it because we can find some scripts that try to register an extension with some simple passwords and make phone calls to some payment number. So it's very important to choose it carefully. The display name is the name that has been shown in the display of the phone when an incoming call arrives. And the WebSocket URL. WebSocket URL contains a customized port 889 that obviously has to be reachable by the client, and the WebSocket secure protocol, so all the traffic is encrypted. We can attach an event listener to manage all the related events and call the start on the just created SIP stack. At this point, we register the phone extension, okay, calling the new session API on the just created SIP stack and passing to it the word register and other event listeners to manage the related events. And at the final, we call the register function. Here it is. At this point, if all goes well, we can make a new phone call, calling the new session function on the just created SIP stack and passing to it some parameters that are only the HTML elements, so all uses web standards. And at the end, we can make a new phone call. That's it. Okay, during the years, we have decided to switch the implementation of the SIPphone using Janus Gateway, okay? We're going to see this implementation. Janus is a general purpose gateway made by Mythico company, and it's a WebRTC gateway, okay? It uses the JSON standard format for messages exchange. Its architecture is made by plugin. We have used only the SIP plugin, but other plugin exists, of course. It provides some interfaces for communication and other tools for monitoring that are very, very important in production. This picture, we can see the differences from that of sipML5, because previously sipML5 communicated directly with Asterisk. But now the Janus client communicates with Janus Gateway component, that is a backend component which in turn communicates with Asterisk using the SIP protocol. And all of this traffic is proxy passed by Apache web server, and all traffic is encrypted, of course. The advantage of this architecture is that now we don't worry anymore about the changes that can arise from the evolving of the WebRTC technology, because Janus takes care of it. Okay, now we are going to see how to implement a SIPphone using Janus. So also in this case, 4 steps are needed. The initialization of the engine. Now the JavaScript global object is called Janus. We create a session, attach a SIP plugin. Only SIP plugin is used, but other plugin exists. And at the end, we can make a new call, creating a new offer. Okay, let's go deeper to see more details. The inclusion of the library, we need only 2 libraries. One is Janus, of course, and another one is an adapter that resolves all WebRTC differences between different browsers. We initialize the engine calling the init method, passing to it the debug level and a callback function. And then we create a new session. Notice that now the server address uses the standard HTTPS port, so you don't need to open another port on the server, all using web standards. And we pass other callbacks as parameters. And at this point, we can attach the SIP plugin to have a plugin handler to make a new phone call. In this slide, I deliberately cut off the code to not generate confusion. So other callbacks as passed as parameters. And at the end, if all goes well, we can make a new phone call invoking the create offer function on the just created plugin SIP handler, okay? And we can specify the destination of the call. That's it. Okay, now some few words about the server PBX, because in this case are another fundamental part to make the all components functioning, okay? In this talk, I've used the NetServer VoIP PBX that is based on Asterisk, FreePBX projects, and NetServer Linux distribution. That is completely open source, available on GitHub. It has also a community of enthusiastic people that you can find it on community.netserver.org. You can participate in the project in whatever manner you want, and the enterprise version of the NetVoice, the switchboard system, is called NetVoice, and the NetCTI on top of it, that is a web application with WebRTC phone. To give you an environment to start playing with WebRTC, I've created a VirtualBox machine that you can easily run using Vagrant. I give you a link in the next slide, okay, to know how you can easily run your private PBX at your home. Okay, now I would like to show you an open source demo of an HTML5 SIP client to better understand what we have seen until now, okay? So, to recap, 2 steps are needed. We are going to run a server PBX, and for this you can you have to done only 3 operations: clone the GitHub repository, skip into it, and run Vagrant app. At this point, you have your server PBX completely configured. And we are going to open the WebRTC demo at this URL. Then we can insert some default values, okay, that you can find on GitHub. The parameters are the server address, the display name, extension identifier, and the password, okay? Then I'm going to log in, to click the login button to register the phone extension into the server PBX. And at this point, we can make a phone call, of course, okay? Clicking the call button. And we will see a remote and local video, okay? All is on my local machine, of course, for simplicity. Okay, this is one session, okay, I've already inserted the data and running my own private server PBX on my local machine. So we specify the server address, the display name, extension, and password. So in this session, I'm going to insert the extension 200 and log into the server PBX. At this point, the phone extension is registered and completely working. In another session, I insert the extension 201 and log in. And at this point, I can make a new call to the extension 200, audio and video, okay? Here I click the answer button, and I have a new audio-video call. Obviously, this is the remote part, and other are my local part. It's the same image, of course, because all is on local machine. Okay. Okay, come back to presentation for a few slides. Okay, this slide is to show you only to understand that with WebRTC you can make a real product for your customers. So this is the NetCTI made by Netesys to make new audio-video call with WebRTC. It abstracts many devices into one single user using a customized layer of REST API that is independent from the specific version of the Asterisk. Okay, as I promised you, this is two links. The first contains all the important related links of this talk, and the second is a very interesting WebRTC blog made by Taki Levy. Okay, it's very interesting. And if you want to discuss something about WebRTC, some development of a server or whatever, everything else, these are all some of my contacts, and I will be very happy to talk with you. Thank you.
We do have time for a couple of questions, I believe. So does anybody have a question?
Hi, probably a stupid question, but Janus is not using ICE or Stunner Turn, is that correct?
Yeah, Janus can use ICE and STAN server. It depends on your network topology. For example, in this case, I have my local machine, so I configure Janus to operate in a NAT mode. But if you are connected to the internet, you are behind a NAT, for example, you configure Janus differently, and it can connect to some STAN server to have your public IP address outside your local area network to make all function. Of course, in some cases, you can have some problems, okay, depends on your network topology, and you can use also a TAN server, okay, to relay all the media traffic. Of course, in this case, the TAN server requires a lot of bandwidth because it relays all the audio and the video, very important for bandwidth, video traffic. Okay. You can have different configurations of Janus Gateway.
Any other questions?
So for curious about the sipML5,
Yep.
the project now, who is still by Dubango project, or how it's maintained these days? Because
It was started by Dubango Telecom, that is a French company. Then also Google promoted it in about 2012. I don't know very well the details of what is the maintainer, but is present on GitHub, and I think that some Google developers works on it. I don't know very well, but probably also Dubango works on it. Thank you
Thank
to
you,
all.
Alessandro.